Good morning everyone, I'm Terje, and today I will show you how you can use a Nastran DMAP in order to alter the execution of a standard solver in NX. And in this example I will run a DMAP which is altering the SOL103 execution in order to perform a component mode synthesis reduction. That means how to create superelements that I later can use in Fedem. You might not know that all solvers in Nastran is based on DMAPs, and you can also alter these DMAPs. You can compile them with the list option, and then you can see the contents of those routines, and you can then add your own stuff in there in order to alter the execution and create your own solver. First, I'll show you how to do a component mode system synthesis model reduction of Fedem parts in NX. How you can add the DMAP commands, additional DMAP commands required to alter the SOL103 execution, and how to export Nastran bulk data files to Fedem, because you don't only need the model reduction files, the reduced mass and stiffness matrices and the gravity vectors, you also need the Nastran bulk data file for display purposes in Fedem. I'll show you how to run the component mode synthesis in NX based on the SOL103 solver. I will also show you how this DMAP looks like inside, and then how to copy the OP2 files and DMAP to the Fedem part folder in order to reuse the super elements in Fedem. And then how to import and run the Fedem solver with the reduced parts from NX. And I'll also tell you about the current restrictions. So stay tuned. This is my NX model, and it's a model of a subsea template for an offshore windmill made of beam elements. And I will use this model as a super element or part in my Fedem assembly. In this example, I want to keep 5 nodes as external nodes. That means triads in Fedem. I will define an ASET which corresponds to the triads. And in my ASET, I will put this node, and this node. Those are 3 nodes I will fix to the seabed. And in addition, I will keep the lower node here in the tower and the upper node as external as well. That means I will have a total of 5 external nodes in my super element. These will have each 6 degrees of freedom. So that means I will have a reduced mass and stiffness matrix for which has the size 30 by 30. In addition, I want to add 3 fixed interface normal modes. That means component modes that I will have when I keep my external nodes fixed. And I'll show you how to set it up. This is a beam model, and I just display it as a solid model by changing the view settings in my FEM model. Let's have a look at the file or the solution setup. You see I choose SOL103 because the SE modes routine or DMAP, which is the basic DMAP for this solver, is containing all the functionality I need to run a component mode synthesis reduction. First, in the file management section, I have to assign some extra files. Here you see I've assigned one file called tripod_m op2 with the file unit 71. And when I assign it to give it a file type of output 2, that means this is in binary op2 files. In addition, I open or assign another file for the reduced stiffness matrix, another one for the gravity vectors, that's also an op2 file, and then one file for the static modes and one file for the fixed interface normal modes. So these assignments will be added to my bulk data file, and they will open up 3 or 5 op2 files, and these op2 files must later be copied into my part folder, Fedem part folder. So these files must be stored in the same folder as the DMAP and that file, the bulk data file that I import in Fedem. And when Fedem detect these three assignments in my bulk data file, it understands that the model is reduced in NX Nastran. Then in executive control section, I have to include or add the DMAP statement. And in NX 11 and the current version of Fedem, that means 7.2.1, this file need to have exactly the same name as this statement, Fedem underscore DMAP underscore I02.dat. If you give the DMAP another name, this setup won't work. So you have to copy exactly this text string into your key in text section. So you need to write include in small letters as well. This will change in later releases. By the way, the documentation in Fedem is not updated, so you have to follow this video in order to make it right, not the documentation. So that's the command, the DMAP command for reading the DMAP. The next thing you have to do is to go to the case control, and you have to specify the number of component modes. And here I've selected 3 component modes. And then in the bulk data section, I have to define my ASET and QSET. And there are probably several places that you can add this text. You could probably add it here as well, but I'll show you how the final that file needs to look like in order to run with the DMAP. So here you see there are 2 ways to define the ASET. You can use the ASET command, and the syntax is as follows. First the node number, and then the external degrees of freedom. 1, 2, 3, 4, 5, 6 means that all degrees of freedom are treated as external. And then the next number, node number, and the same degree of freedom list, and you repeat it for each node and degree of freedom list. In this example, you see I've added a comment or a $sign in front of the ASET command. That means that this will be treated just as a comment. It's not active. I have to remove it in order to make it active. Here I use the ASET instead. I use the ASET1 command, and then I give the degree of freedom list first, all degrees of freedom, and then the 5 nodes that I want to keep as external or super nodes, or triads if you like. Then I add another statement, which is the scalar point statement. And here I need to define 1 unique scalar point for each component mode. And you must make sure that these node numbers or scalar point numbers are not coincident, or it must be unique. You must give them high numbers so they are not messing up the node numbers, because if there is a node in your model with the same number, this routine will fail. And then you have to define the QSET for these scalar points. And you have defined that there is 1 degree of freedom for each scalar point. And you have to repeat the scalar point numbers here in the QSET command. So this setup gives me 3 additional fixed interface normal modes. And that's all you have to do in order to run NX Nastran with a DMAP. And it doesn't matter what kind of DMAP you're running, but you have to assign the same commands in the same sections of the NX user interface. In this example, you can notice, well, let's first run the DMAP. I can run solve. It's a small model. There it's completed. Cancel. If you take a look at the modes here, you will notice that I have 3 modes, but these are rigid body modes. They have 0 Hz as an eigenfrequency. And that's simply because we haven't added boundary conditions to this model. So it's not restricted in any way. However, the DMAP I've provided here or use, it will automatically set up the CSET as well. And the CSET is identical by default to the ASET. That means when you run the component mode synthesis, the CSET or ASET will also be kept fixed. That means that if you compare the modes that we calculated and post-processed here in the user interface, which had 0 eigenfrequency or 0 Hertz as eigenfrequencies, those are the rigid body modes. They are not the same modes as you will find in the FO6 file. Here you see that the first 2 eigenfrequencies have an eigenfrequency of 6.2 Hertz and the last one 6.7 Hertz. And these are the fixed interface normal modes that we want to use in Fedem. You should also know that in the DMAP that we will have a look at, you can add commands in order to output the reduced mass matrix, the stiffness matrix, the gravity vectors, the component modes or the static modes, and the fixed interface normal modes to this FO6 file. And I'll show you how to do it. Here you see the DMAP file I'm using in order to alter the execution of SOL 103. I won't go into the details because this is pretty much a routine made for Fedem purposes, but I'll show you the basic principles. First, here you find a compile statement which is compiling this routine called phase 1 DR. And if I compile it with the option list instead of no list, the contents of this routine will be printed to the FO6 file together with the line numbers. And then you can jump to certain positions in this routine by either using the malter command, which is searching for a text string. In this case, when the system finds this text string, it has already performed the component mode synthesis reduction, and these 2 matrices, MAA, reduced mass matrix, and KAA, reduced stiffness matrix, is already calculated. And therefore I can output them to my OP2 file, which I've already assigned. The other option is that when you have printed these routines, you can use the alter statement here. And this means that here, for example, I've compiled the routine called SEGOA, and then I jump to line number 1 in this routine by specifying alter 1, and then I'm adding command sequences to this DMAP, this basic DMAP. Here, for example, I've copied 2 files, or I defined 2 additional new user routines or user files or matrices. And here I jump to line number 11 in order to add another 2 DMAP commands, which is tailored for my need. And here you see I've written out the static and component modes to 2 OP2 files, which I also assigned. You can also notice that this routine here is printing these routines to the FO6 file. In this example, I've commented out, so it doesn't actually dump the matrices to my FO6 file. And that's pretty much how it works. What you need to do is to search in the DMAP documentation in Nastran. It's about 1800 pages of descriptions of user routines. And if you think you have found the routines that do the job for you, you can compile it with the list option to see the contents, and then you can add new commands or alter the execution of that routine. So that's how it works. So now will show you how the bulk data file that you can export to Fedem will look like. So here is my input file to the Nastran solver. And here you will find first the file assignments that are added in the file section of the SOL 103 setup in the user interface. Here are those files. And then here you will find the include statement that was in my file section. Then further down here you will find the mode requests, the request for 3 modes. And then in the bulk data section I've added the ASET and the QSET commands, and here they are. These are the last DMAP commands I added in the simulation setup. So this is the input file that will be run by NX. This is also, you can also input this file into Fedem, but that's not the intention. This is the file that you use in order to calculate the OP2 files that we need. But I'll show you now how to export the file that you want to import in Fedem. Here is the model again, and we have already executed the component mode synthesis. And the next thing we have to do, we need to export the Nastran bulk data file to Fedem. So we go to File, Export, Simulation. And then in Fedem, we usually use Newton meters and kilo SI units. And then we select the file location, and we go to links. And here we can give it any type of name, but in Fedem we usually use the extension .nas instead of .dot or BDF in order to identify that these are files for bulk data files for Fedem purposes. So we can call it test dot. We change the file type to NAS file, and we call it tripod Fedem. Okay. And now we have exported this file to Fedem. The next thing we have to do is to copy the OP2 files to the same folder. Here we have the OP2 files that we created. We don't want this one because this is not the one of the superelement files that we want. This is the file that contains the results that you can view in NX. But here you see this reduced stiffness matrix, the reduced mass matrix, the gravity vectors, and the static and component modes. So we copy these files to the folder where we have the bulk data file. So in this folder we have the DMAP, we have the OP2 files, and we have the Nastran bulk data file that we exported. So the next thing we will do now is to import the model to Fedem and run it there. Here I have an empty model database, Fedem model database, and now I can load the part, and I select the Nastran bulk data file that I just exported. And here you can notice that the external nodes, which are marked as ASETs, they are identified as green triads in this model. And then we can have a look at the list view here. And here you see that Fedem has identified the OP2 files, the extra OP2 files. It has also noticed the set assignments in the bulk data file. And then Fedem understands it shall open these OP2 files. You see here, OP2 files were detected. The FE part is assumed to be externally reduced. That's the message. And then you can take a look. If you click on the part here, then you see that the model is marked as reduced. You can also go to the Results tab, Result File Browser, Reduction, and you can see that it's marked with a green dot, which means that Fedem has access or actually converted the three OP2 files with the reduced stiffness, mass, and gravity vector to the FMX binary format, the Fedem binary format. So that means that we have been able to successfully import the model to Fedem. Here I've complemented my Fedem model with the free joins in the support nodes where the template is supported to the seabed and I've assigned properties. I've also added a load on top here, and now we see the animation is running fine with the reduced model from Nastran. And remember, by using this technique you can use finite element types which are not supported in Fedem in your finite element simulation or your Fedem simulation. You could use composite elements or any type of element. What you need to be careful with is to change the triads. That means the supernodes in Fedem. You can't change anything really. If you by accident delete one of the free joints here and you also delete the triad, you have to import the model again in Fedem, because then there will be no correspondence between the reduced superelement matrices from NX and the Fedem model that you see here. So you have to model with care when you use externally reduced models. This is, if you have questions regarding this, you can contact me. It's quite straightforward as long as you remember to copy the OP2 files to the same folder as the Nastran build data file. And you also need to put your DMAP in the same location at time being. In future releases of Fedem, this will be automatically taken care of. So thanks for watching.